Previous class we were discussing on Stokes lines. So we discussed about the energy gaps in Stokes lines, and today we will discuss about of anti-Stokes lines have energy gap. So we see that these are that energy gaps. We see that whenever we give this h nu energy, and that is for Stokes lines, this is h nu dash is lower. So whenever you calculate it, that is you are subtracting it, that delta E, and whenever you discuss about anti-Stokes, so this is lower and this is higher. Whatever the energy released is higher, so we are adding here. Okay, so here that for anti-Stokes, that h nu dash equal to h nu plus delta E, and this that we have discussed in the previous class, that is plus delta E, and this delta E is equal to b j that is b for j plus 6. So this h nu dash is equal to, I can write h nu plus b for j plus 6, and this transitions here is j 2 to 0, because you see that here the selection rule delta j equal to -2. So what actually doing that, let's say this is here the molecule says we get this molecules here, and whenever it goes here, after that it will doing the transitions from here. So from 0 to, or let's say here, if we give that, I can draw here. So here if we see, let's say this is j equal to 0, j equal to 1, this is j equal to 2, this is j equal to 3. So transition is giving that electromagnetic radiations here. So let's say it is from 2 to 3, to that this is going to here. So this is the h nu and this is the h nu dash. Okay, so this is the energy gap. So what you see is that h nu dash is equal to h nu plus this is the delta E. Okay, so this is, I can draw this. So this delta E is from where? From 2 to 0. So this is the transition from 2 to 0. Okay, so that's why I say here that h nu dash equal to h nu plus b for j plus 6, and this is from j 2 to 0, and here we take this j value, here this j value is higher transition value, means this we will take that 2 j to 0, you are coming, this is 0, so you will take this higher value, that is 0, because delta j is j final minus j initial. So here j final is 0, j initial is 2, that's why you get -2. So here j final is 0, so you will take that here the final value, here the transition the higher, or we can say that final rates will take. For Stokes lines we are taking the initial value or the lower value. Okay, for here we will take the final value. So here we get, so h nu dash equal to h nu plus b for j b for j plus 6, and this h nu plus b, this is final value. Here we get here for j 2 to 0, I put the higher value, that is 0, so 4 into 0 plus 6. So this I will get h nu plus b, this is 0 plus 6, that is h nu plus 6b. This is the h nu dash. So if I go for, so this is h nu and this is 6b. Okay, so this is the h nu. So first we will get at the 6b. Okay, so another, if you go for let's say I will go for, first I'm going 2 to 0, I'm going 1. If I say come from 3 to 1, so j equal to 3 to 1. On that case, again we see that delta j is equal to j final minus j initial, final is 1 minus 3, that is again minus 2. So here we will get delta nu equal to delta nu plus b for j plus 6, and here that final is 1, I will put h nu plus b 4 into 1 plus 6, that is equal to h nu plus b, that is equal to 4 1 4 to 6, that's 10. So here I will get h nu plus 10b. So next I will get at 10b 6b, another h I will get 10b. Okay, after that again if I go now I will go from 4 to 2 j 4 to 2, then I will get h nu dash equal to h nu plus b for j plus 6. So here h nu plus b, that is here higher one is 2, so I will put 4 into 2 plus 6, that is equal to h nu plus b, that is 8 plus 6, that is equal to 14. So where we get h nu plus 14b. So another will be from here to 14b. So here we see that if this is the 6b, then 10, that means this is the 4b, and this again this is the 4b, and again you will get 4b 4b. The gap is 4b 4b 4b. Okay, so if I draw these pictures here, let's summarize it. So first is relay lines. So here whatever the energy gives, suppose here to here, this is, let's say j equal to 0, equal to 1, j equal to 2, j equal to 3. So these are the relay lines. First this is the relay lines, and next is anti-stokes and stokes. Here that whatever this is the h nu, then this is the same h nu. Here h nu equal to h nu. Okay, and next if I draw, so if let's say for stokes lines, so here given this h nu here, so this h nu has released. So here we see that this h nu is greater than h nu dash. So here we see that this h nu is equal to this is h nu dash plus delta E, and we are talking with respect to h nu, so I will write h nu dash equal to h nu minus delta E. Here h nu equal to h nu plus here delta E is 0. Okay, and next this is the for stokes lines. And next we will talk about the anti-stokes. So here also I can draw that. So here also, but here we are giving that h nu to the excited states. Let's say this is also j equal to 0, j equal to 1, j equal to 2, this is j equal to 3, this is also j equal to 0, j equal to 1, j equal to 2, this is j equal to 3. So here also same things, this will be h nu dash, this is the h nu. So here we see that h nu dash is greater than h nu. So I can say that h nu dash So this is the delta E value. So this delta E is this value. This is the delta E, and here also this is the delta E. So if I add h nu plus delta E is equal to h nu dash. Okay, so this one I can write h nu dash equal to h nu plus delta E. This one I draw in this. This one I draw here, that this h nu relay lines I will draw here. This is h nu, and here that from this if I subtract here, this is subtracting means h nu minus delta E. That is the, this is the Stokes lines. So this is the Stokes lines, and here I am adding h nu, adding delta E from here, that is h nu plus delta E, that is anti-Stokes lines. So here we see that spectrums, you will see this, let's say this here. Like this spectrums may be like this intensity, different intensity it have, that depends on the multiples how it is like intensity. So what we know that is that this energy gaps from here to here is 6b, and this is also 6b, and these gaps are 4b, 4b, 4b. These are 4b, 4b. These are the 4b. These are the 4b, and these are also 4b and 4b. These are the 4b, 4b. So past relay lines to the past Stokes or past anti-Stokes are 6b, 6b. After that, individual two consecutive Stokes lines or anti-Stokes lines are 4b, 4b. So here I can write, we can write some points. So the difference between relay lines and past Stokes or past anti-Stoke is 6b. Here also 6b, here is 6. From this is the relay lines. So from relay lines, past difference between the relay lines and past Stoke or past anti-Stoke line is 6b, and the two consecutive energy gap or for Stoke or anti-Stoke is 6b. This is 4b. Okay. So, and if the questions ask that what is the difference between the past Stokes and past anti-Stokes, then that is 12b. Yes, from past anti-Stokes to past Stoke, this distance is 12b. It is 12b. So it asks that the energy difference between past Stoke and past anti-Stoke line is 12b. So like this, if you draw the picture, after that whatever the questions that ask, definitely we will give the answers. So we know that this is the picture of spectrums where that past the relay lines and anti-Stokes or past Stokes will be 6b. Okay, so next we will move on that effect of nuclear spin. Next topic as effect of nuclear spin. Here what we will discuss here is that for this effect of nuclear spin, some conditions are there, that is